Hey guys, we're going to talk about the differences between circles and an ellipse. An ellipse is just a perfectly shaped oval, so it still has a center with a measure in both directions, just kind of like a radius for a circle does. So we're going to talk about how to graph them. The first thing though is we have to make sure that's equal to 1 before we can solve. This form that you see right here is called standard form. It's with the parentheses and the squares. So what this means is in the traditional equation, inside the parentheses is opposite what we think. And this is my center, the middle of my circle. So when I am graphing this, I'm going to go to -2, 1. There's the center of my ellipse, okay? The next thing I have to do is I need to see where my ellipse boundaries are. So what I'm going to do is I'm going to make this a fraction and put 1 under it. I am going to square root the bottom of my fraction, and then this square root tells me how far to go from the center in every direction. So from x, the square root of 1 is 1, so it says to go 1 to the right, but also 1 to the left. This is associated with the y. The square root of 1 is 1, so that means to go from the center 1 up and 1 down. So this ellipse ended up being a perfect circle. Okay, so for our next one, my center is at 1, -2, because 1, -2. Then I need to find my vertices. So I'm going to square root, and so this is 2. So one of my vertices is 2 to the right and 2 to the left. And that just tells me how far to go in each direction. Next, I'm going to square root this one. So that's 3. The square root of 9 is 3. I'm going to go up 1, 2, 3. And then down 1, 2, 3. And then I'm just going to kind of make it. So this side is longer than this side. The longer side is called our major axis. The smaller side is called our minor axis. Okay? So the next thing that we have to search for is called a foci. A foci just means a center point within our ellipse. So I'm at 1, -2, and then I went down 1, 2, 3, and then up 1, 2, 3, and then to the right 2, and then over 2. So here it is. There is a dot in the center of this that if I were to hang a rope on, and then the center dot on the other side, it would make a perfect triangle. No matter where I place it, it would make a perfect triangle. And the idea of it is that if I were to hang a piece of rope anywhere on this curve and attach it, this string would hold up the bridge perfectly. So picture a bridge going across, the foci are in the middle of the bridge, and let's say the safest place to hold the rope is here, and then attach it there. This bridge is going to stand. So how do we find the foci? All you do is you're going to take your major minus your minor, and then square root it. And that's going to give you your foci. So ours is going to be 3 minus 2, square rooted. Square root of 1 is 1. So our foci is 1. This last form is the most complicated. It's called our general form. So the first thing we have to do is get all the constants to one side and then rearrange so that my x's are with my x and my y's are with my y's. Next, I'm going to pull out just the numbers. Don't pull out the variables. 9x squared minus 2x. And I'm going to leave a space here. And we're going to figure out that number in a second. Plus 4y squared minus 4y plus a space equals 11. What we're trying to do is get back into our other form here. So what I can do here is I'm looking for two numbers that add up to -2, but multiply together. So -1 minus -1 gets me to -2, but -1 times -1 gets me +1. Here, it's going to be -2 times -2, which gets me to +4. But -2 added to -2 gets me to -4 here. Okay? Since I just added arbitrary numbers, I have to add arbitrary numbers on the other side of the equal sign to make them even. So what I do is the number I pulled out times the number I just added for fun, I have to add to the other side, so 9. And then 4 times 4 is 16. I'm going to add all those together. And I get 36. The next thing I'm going to do is I am going to factor this to x minus 1 squared. Because -1 times -1 gets me to 1, but -1 plus -1 gets me to -2. I'm going to do the same thing over here. And it's going to be -2 squared. Why this is useful is I can divide by 1 to get this to 1, because that's what we wanted in the first place. So now I have 9x minus 1 squared over 36 plus 4y plus 2 squared over 36 is equal to 1, because 36 divided by 36 is 1. Now I can reduce these fractions, and I get x minus 1 squared over 4, and then y plus 2 squared over 9 is equal to 1. Now this is the exact same form as our other example. All right, email me if you have any questions.